Hi students, and welcome to 8th grade lesson 1. To begin with our lessons, you are going to need your student companion book, which is the consumable softcover book, and then you'll follow along with that book while you watch this video. So you can open to lesson 1 and look for the launch that looks similar to this, and we'll go ahead and try this first problem together.
The workers at the local lasagna shack share their tips evenly and entirely at the end of the night. A war of words always erupts when they cannot seem to share the last dollar entirely evenly. Which nights will workers argue? Why?
Okay, so on Monday, the last dollar is $1, and there are 2 workers. Will there be an even split? How much would they split that dollar to be if they're sharing it evenly and there's 2 workers? How would they split that? How much would each worker get? So we're going to write how much each worker would get in this even split section. So you can go ahead and pause this video and then try these questions on your own. And then we'll go ahead and do them together on our notepad. All right, so if these 2 workers split their dollar evenly, they would each get 50 cents. Oops, that period needs to show up there. There we go. Here, if they were to split it evenly, yes, they could do that, and a dollar divided by 4 people would be 25 cents. And here, a dollar divided by 3 people, ooh, they can't do that evenly. It's not going to be an even split. A dollar divided by 5 people, yep, that'd be 20 cents. And divided by 6 people, that's another one where we're not going to be able to split that evenly amongst the workers. So the days that they would argue would be Wednesday and Friday, if we go back to the original question. So today we're looking at the term that is called a rational number. And if you look at the word rational, you'll notice that it has the word ratio inside of it. So a rational number is a number that can be written as a ratio. And ratios can be written as fractions. So a rational number is a number that can be written in the form of a fraction. And they use the letters A over B just to represent 2 different numbers. So a rational number is a number that can be written in the form of a fraction. And then it just says that A and B are integers, which just means they're whole numbers, and B can't be 0. So this denominator cannot be 0. All right, so rational numbers can also be written in decimal form. So that's something else because we can always change fractions to decimals and decimals to fractions. So therefore, rational numbers can also be written in decimal form. Okay, so let's look at the 2 kinds of decimals that we can have when we work with rational numbers. The first kind is called a terminating decimal. So in a terminating decimal, you have the fraction 9 over 5. And if you were to get a calculator out, in fact, I'll grab mine here. This means 9/5 or 9 divided by 5 because this fraction bar also represents division. So you can do 9 divided by 5, and that's going to give you 1.8. So the decimal form of this fraction is 1.8. We can do that with all of them. 1 divided by 4, 4 divided by 100, and even this one, 5 divided by 1. We get all of these different types of decimals, and they all have what's called a terminating end. They all end, and they don't continue on forever. We can see that it's 1.8 exactly. It's not 1.8273965 it's 1.8. Versus what we're about to see is called a repeating decimal, and these are decimals that continue on and on and on forever, and they're represented with this little repeat bar above the number. So for example, 1/3 is a decimal that always repeats. So we can go ahead and take the fraction 1 over 3, 1 divided by 3, and we're going to get this really long repeating decimal. It repeats over and over and over again. And in fact, anytime you have a denominator that's a multiple of 3, you're going to have a repeating decimal. So this one is 4 over 9. 9 is a multiple of 3. And there's your repeating decimal. Okay, and we represent repeating decimals by putting the repeat bar over the number that repeats. Look at 7 over 15. This one has the number 4 in the tenths place and 6 in the hundredths place. But the 6 is the only number that repeats, so we only put the repeat bar over the 6, not the 4 and the 6, just the 6. Let's look at this one, 49 over 33. This one repeats in a pattern at 4, 8, 4, 8, 4, 8, 4, 8. So the repeat bar goes over the 4, 8 because that is the group of numbers that's repeating. All right, so for our next example, it says that Allen wrenches are often needed to assemble furniture. One commonly used size is 3/16 of an inch. What is 3/16 written as a decimal? So to do this without a calculator, you need to know that we work with fractions from top to bottom. So the 3 is divided by 16. So 3 is divided by 16. Okay, because all fractions are division problems in disguise. So we're going to ask ourselves, well, how many times does 16 go into 3? It doesn't go into 3. So we're going to add our decimals. Oops, add those decimals and extend our division bar. And then we're just going to add a placeholder because 3 is the same as 3.0. We didn't change the numbers, we haven't changed anything. We're just giving ourselves more digits to work with. So now 16 goes into 30 how many times? Well, it does. It goes in one time. 1 times 16 is 16. We'll go ahead and subtract and bring down what's left over. So we've got 14 here. And we're going to add another placeholder so we can work with that number. Again, 3 is the same as 3.00. So now we're asking how many times does 16 go into 140? Well, I know that 16 goes into 160 10 times, and I'm going to say it goes in 8 times to try it. 8 times 6 is 48, and 8 times 1 is 8, plus 4 is 12. And subtract this, and I'll get 12. I'm going to add another 0 to keep going. I want to look to see if this number is going to repeat or if it's eventually going to end. So I'm going to keep going for at least 3 or 4 decimal places. How many times does 16 go into 120? Well, it went into 148 times. That was 128. So this is going to be a 7. 7 times 16, 7 times 6 is 42. 7 times 1 is 7, plus 4 is 11. We'll subtract and bring down. This will be the last time I try this. So 8, we'll add one more 0 just to see. Bring this 0 all the way down here. Ooh, 16 goes into 80. I think it goes in, does it go in 5 times? Let's try it. It might go in 5 times evenly. 5 times 6 is 30. Carry the 3. And it does 80 evenly. So you're going to want to go about 3 or 4 decimal places out to see if it does eventually repeat or terminate. This one does not repeat because at the end here we got a 0 that's left over. So that means this is the end of our decimal. So written as a decimal, 3/16 is 0.1875. All right, so now in your student companion book, I want you to try this one on your own. So it says that this one is a 5/32 inch, so they want 5/32 written as a decimal. Go ahead and try it on your own and then come back to check your work. All right, let's go ahead and take a look at the solution. Wow, it was a long decimal, but if you got it, you would find that it eventually does terminate. Here's this if you'd like to take a screenshot or pause the video to check your work. That's on the screen for you. So now we're going to move on to example 2, and here they want us to decide whether or not each one of these statements is equal or not equal to each other. So we're going to start with this first one, which is 5 over 9. And this means 5 divided by 9. And for the sake of time today, I'm going to use a calculator to do this. So I'm going to say 5 divided by 9 is 0.55555 repeating. So that means 0.5 repeating and 0.5 repeating are equal to each other. Okay, and make sure if you are using a calculator on this that you do the division in the correct order. For example, for letter C, this is 7 divided by 6. So you have to enter it in the calculator that way. 7 divided by 6 is 1.16, and the 6 is repeating, not the 1, just the 6. So this is true. Let's try 1 divided by 11. 1 divided by 11 is 0.09, but the 0.09 repeats, and this does not have a repeat bar, so this is not equal. Let's try 13 over 5. It's 2.6, and this is 2.6 repeating, so that is not equal. Let's try 5 over 37. And if you're dealing with negatives, don't worry about trying to put the negatives into your calculator. Just do the fraction work first and then come back to remember your negatives later. Here we have 3 digits that are repeating, 135, 135, 135, and the repeat bar is over 135. So this is a true statement. And negative 10 over 6, we'll plug that in. 1.6666667. The 6 is repeating. Even though this does end in a 7, that just means your calculator ran out of room and it rounded up at this point. So 1.67 is not the same as 1.6 repeating. So we need to put this as not equal, and then we'll check our work. Now I want you to try the got it in your book. All right, let's go ahead and check our work. So the fraction 3/9 written as a decimal is 0.3 repeating. All right, here's our next problem. It says the main span of the Brooklyn Bridge is about 0.3 miles long. The main span of the Williamsburg Bridge is about 10/33 miles long. Which bridge is longer? Let's add this to our notes. Okay, so we need to know which is longer. We can do one of two things. We can either convert this fraction to a decimal, or we can convert this decimal to a fraction and compare. I'm going to convert this fraction to a decimal, so I'm going to do 10 divided by 33. And for the sake of time, I'm going to plug that into a calculator. So 10 divided by 33 is 0.30. Let's see where this is here. Was it 30 repeating? Yep, 30 repeating. And we do need that 0 here because the 30 repeats in a combination. So it goes 30, 30, 30. So now we need to ask ourselves, which is longer, 0.3 or 0.30? And if we look at this, we have 0.3, so we always compare place value to place value. So zeros are the same, the 3's are the same. This technically is a 0 here. And then we actually have to add on more decimal places here because we need to compare more numbers. But here we know that this is a repeating fraction, so it's going to be 30, whereas this is a 3. So now we can officially say that the Williamsburg Bridge is longer. Now complete the close and check your work.